Good afternoon, everyone. Welcome to the fourth webinar of the CS Professional Development, which is designed to promote coding activities within the BPS Hour of Code period. Today's webinar will focus on the game programming concepts such as iteration, recursion, variables, understanding certain concepts of programming using the tool called StarLogo Nova. So without further ado, as a team, we'll quickly introduce ourselves. I'm Rashmi Pimprakar. I'm Program Director for STEM Initiatives and Graphics and Film Production Design, which is also multimedia. And I will pass it over to Charlotte, who will introduce herself quickly.
Hello everybody, my name is Charlotte Corbett and I'm the resident nerd for the Horace Mann School for the Deaf and Hard of Hearing. I am actually the technology specialist, computer teacher, and media specialist for the school. I am very pleased to be here.
Before we go on to the agenda for the day today, could you please make sure that you have logged into the BPS Google Classroom for the game programming StarLogo Nova website. Most of our links for today's handout, the activity that we are doing today, as well as the orientation is posted on our Google Classroom. Also, please make sure that you open up a tab and log in to the today's meet. Your today's meet will look like this, wherein you can post questions. This is a place where you can post questions, you can post information, as well as ask for links. The graphic that you're seeing right now is it's a quick snapshot of how computer science is being implemented in BPS at different grade levels. What you're seeing right now is a pre-KK, elementary, middle, and high school distribution of different courses, different programs and initiatives that are being implemented in BPS. Today, as the graphic shows, we are focusing on the game simulation with StarLogo project. And if you see at the bottom of it, I would definitely like to recommend you to exploring computer science, the AP Computer Science curriculum, Python programming, which are semester-long or year-long courses that you can implement in your classrooms. In addition to that, we also have Visualizing Mathematics, which is a computational course that you can then integrate into your mathematics or science classroom. So that's another way you can look at implementing computing in different aspects of your subject area classrooms. Having said that, this is the quick overview of the agenda that we'll be following today. We'll talk a little bit about the global, as we call it, the movement called the Hour of Code, which encourages students, of course, educators and industry people, along with all of us, to get involved in the coding movement so that all students get at least an hour of coding experience during this timeline so that they get immersed in it, they love it, and then they continue learning more about it. As more and more we know, computing is more like literacy that is so much essential in our everyday life. So we'll talk a little bit about that and the opportunities that Hour of Code and code.org provides us. We will then go into the game programming with StarLogo, which is, again, it is a graphical programming environment which is developed at MIT to enable students and teachers with no prior programming experiences. It allows them to create and study games and simulations. It facilitates the creation and understanding of simulations of complex systems without really being cumbersome. It is a great tool for programming educational as well as socially responsive games, and BPS is really very lucky to have this partnership with MIT StarLogo team, which is supported through NSF and the Lindy Foundation in Boston. I would like to introduce Shar, who is one of our lead StarLogo educators in the district. She also implements this with a range of her students from middle school to high school, and we look forward to hearing from her not just about the activity but also how she implements and what are the different collaboration opportunities that comes along with it. This is a traditional StarLogo Nova, which is our online interface, web interface for StarLogo. I'm going to quickly scroll up and give you a really quick introduction to what the interface looks like. Right up here is the gallery, and as you can see, if you've registered for StarLogo Nova, you can see that the profile that you've created looks somewhat like this. You have a run code option that Shar will talk a little bit more about once we do the activity and create our code. Right here is the Ticks versus Mountain Lion, which is the name of the project that I've given. This is the description. You have a lot of widgets or buttons that allow you to work through importing sound, maybe adding a project to the gallery, and again I'm going to refer to Shar when she talks a little bit more about the remix feature, which allows you to integrate certain projects into your existing project. Right down here, what you see are all the widgets again, which allows you to edit breeds, reset camera, zoom in, zoom out, and what you see here, which is the green, we call it the space land or the web land, which allows you to see some interaction between the 3D objects, or the agents as StarLogo loves to call it. And if you have a graph that you are programming within your game, then you can actually view that right up here. And the third portion of StarLogo, which is one of the most important portion, is this programming environment, wherein you can, if you look at the left, there are agents, and the agent box opens up such that you have multiple options. There are detection, environment, interface, and as I click on it, you see that my options change. These are drag and drop. You can bring it into your programming mode, as you can see here, and we have constructed two scenarios wherein the program is running. This is your space where you program, and you can set up and you can run this program. So without further ado, I'm going to switch over to Shar so that Charlotte, sorry.
That's good.
I'm going to switch over, and she's going to give us a preview of orientation and then run us through the game programming activity for flies, catching flies. Thank you, Shar.
Thank you, Rashmi. StarLogo Nova, or StarLogo TNG. TNG stands for the next generation. TNG is a standalone application that runs on your computer, and StarLogo Nova runs on the web and runs on basically any computer. What they found was that TNG had a really high requirement for displays, and the web one doesn't. So Nova is the one I use at my school. I use it mostly with students who are in middle or high school. I really don't use it with my younger students. I use Scratch for them. Anyway, on the second page of the slideshow is one slide that pretty much summarizes everything. Here in the background is the StarLogo Nova remix, save, next drawer, run code. Remix lets you save a copy of a file, possibly somebody else's, into your own gallery. So the whole idea about this online community is that you can grab somebody else's application, someone else's program, if they allow you to make it public, and then you can modify it further. So you could throw in graphs, or you could gamify it. You could do any number of things. So remixing is nice. It allows you to take a copy of somebody's program and modify it. Save just saves. Next drawer, nobody knows. No, actually, Daniel at MIT hasn't gotten back to me on that yet, so we'll let you know. And run code compiles the code before running the program. Compiling just basically means converting it into a machine language that the computer can run. Below that is, you see the agents. Those are the pull-down menus for the various plug-in pieces that you can use. And then over here, Turtle, Everyone, the World. You may have heard Rashmi talk about breeds. You can add more breeds. So in our particular scenario, we're going to be adding flies and frogs, and maybe Venus flytraps if we have time. Then there's programs that affect everybody, programs that affect the turtle, and programs that are part of the world. Then the widgets allow you to add in things like setup, forever, catching flies, reset. Edit breeds lets you create a breed. Reset the camera, the point of view of the camera. Zoom in, zoom out, and agent view, how you view the agent. So that's a quick and dirty interface, introduction to the web logo, StarLogo Nova. Sorry. Our web logo can do. All right.
So we are again going to make sure that you have your StarLogo Nova registered and downloaded on your machine. TNT is the version that you can download on your machine, and Nova is the one, as Shar referred to it, it's the web version, which is very robust and you can use it. So for today's purposes, you should be looking at your StarLogo Nova version. Right. In your Google Classroom, what you have is this assignment that I have posted, which has the orientation slides that we talked about and the handout that goes along with it. We also have the catching flies activity, which we'll be performing right now. So just please make sure that you have the PDF open with you as we do the activity, because some of the commands, while we're telecasting may not pronounce or sound as well. So if you have the handout ready with you, you'll be able to follow through. What we also have in here is an addition to catching flies, which is an addition for gamification of catching flies activity. So I highly recommend opening up that PDF as well. And I'm going to turn over to Charlotte so that she can get started with the activity.
I'm going to go to Chrome right now and call up my profile under StarLogo Nova. It looks a little different than TNG. I found not knowing TNG and going to this was very easy. Learning TNG and then going back and forth made it more difficult. So what we're going to do is add a new resource page. So the very first thing is we click here, add a new resource page. The title of it is going to be Catching Flies. And I'm going to say -1 CDC. Only because, because I've done Catching Flies several times and I need to make the name unique. So Catching Flies -1 and then my initials. I hit save, and I'm going to enable commenting and privacy. Well, I'm going to go ahead and edit the page. So I edit the page. Title is set, enable commenting, and add.
They want to see the game again, Char?
Oh, they do want to see the game again. I don't blame you. Here, let me get out of this. Let me just set the privacy. Anyone can view. All right, so if you look under gallery, this one will do. Char's Web is the public gallery where anybody can view and remix projects. And this one is the zombie simulation. So we're going to click on Setup. And as you can see, the gray people are humans. The blue people are you, the cameraman. And then we said, start going forever. There's one zombie in the room, or in the world. And I don't see him or her. The zombie looks white. There we go. There's our zombie. I'm gonna go closer. Now it's nighttime, and you can see the humans are scurrying, and the zombies are getting faster. There's 3 of them now. Humans are running into the houses for safety. And now it's daytime, and the humans go out, and as you can see, the zombies just make it easy pickings, and now there are 6. I'll go closer so you can see that I'm gonna die. I died. All right, so that was my zombie simulation that my students do. Create a new project. It's a blank project. Hit submit, and we'll call it right up here where it says Untitled Blank Project 7. We're going to call it SHAR, Catching Flies, version 1. And documentation, always encourage your students to do documentation. Create breeds. So, with that there, I click save, because you save often. And I'm going to edit a breed. So I'm looking at my documentation, create a new blank project. Second, add breed. So I'm going to add flies, F-L-I-E-S. And I'm going to add frog. Frog. Alright, and now that I've got the 2 characters, I'm going to close edit breeds, and as you can see, I now have frogs and flies in my world. That's section 1. Section 2, we'll go to the world. Ta-da! And what we want to do is have something start the program. So in this particular case, let me just real quickly show you. We have a setup and a forever button. So the first thing we're going to do is, in the world, when someone sets up, hit setup, so interface, when setup is pushed. What we're going to do is we're going to clear the terrain, and the terrain is the environment, and we're going to delete everyone. Everyone is an agent. And by delete everyone, we want to make sure that everything's gone. If you forget that step, you'll realize that it's enough. So, delete everyone. And then, save. And the computer says, the documentation says JSON, but it's actually run code. We'll go on to the next one, because we don't have anything. So, part 3, we're going to create our flies. And that's where the fun starts. So, our flies. We do a create, 10, but the number could be 50, flies. And now, this is where it gets fun. We have to identify their traits. So, the color is going to be, so set my color to black. Alright, and I just want to show you what happens if I don't do the next step. So I set my color to black, and I say setup. And you see this fairly large black dot. So I only created one fly? Is that what it's doing? I don't know. If I add scatter, which is under agents, scatter everyone. And now save and run code and click setup. My flies are everywhere. There's 10 flies, and they're now scattered throughout the screen. What else do I want? That's it for part 3. Going through this real quick, folks, because I want to get to making it into a game. We're going to create one frog. And what color are frogs? Well, in this particular case, we're not going to say anything. Traits. We're going to set the size of the frog. I don't know, you want to say 5? Alright, 5 times the size of a fly. And the shape is going to be a pyramid. So set my shape to pyramid. However, I just want to show you there's a lot of different shapes. There's spheres, cubes, angelfish, bear, clownfish, clownfish 2, dog, dragon, so on and so forth. I think there's easily 30 different shapes. We're just going to go with the simple one because they don't have flies. I hit save, run code, go up to the top, select setup, and there's my frog in the center of the screen. Okay? If I hit forever, nothing happens. And that's just as it should. Alright, so part 5. What we're going to do is we're going to edit widgets. And you see, come on, edit widgets, where it says forever. I'm going to change its name to fly around. Accept. And I'm going to create a new widget. And it's going to be called Catch Flies. Now, is it a push button or a toggle? A push button is on, and the toggle button is like the old radio cars. You remember the old cars radios where you could only press one button at a time, so you had 5 buttons, physical buttons where you press number 3 and all the other ones would push out. Press number 1 and 3 would push out. That's a toggle button. So I'm going to add the widget, and it's bothering my sense of space. So I'm going to move catch flies down below, fly around. And when I'm finished, I click edit widgets, and there we go. So now we have 2 new widgets. We renamed forever, and we added one called Catch Flies. Hit save. As you can see, it automatically saves. And if we were to run, nothing would happen because we haven't done anything with fly around. Go down here and then click on flies. And the interface is while, what do you think? Catch flies or fly around? If you said fly around, you were right. While fly around is toggled, I want you to go forward, movement, 1 space. That's all. Let's do it. Save, run code, and now set up and fly around. And there you go. The flies are moving forward. Now, forward is whatever direction they happen to be facing when they were created. And when they hit the edge of the world, they bounce back. So in a 90-degree turn. So there's the flies. Go ahead, brush me.
Go ahead.
All right. So right now the frog is not doing anything. Now, we're going to flies. We're now on section 7, which is while catching flies. So interface, you have to go to the frog. While catch flies is toggled. We're going to move forward 3. Now, catching flies is a simulation. It's not a game. And that's a significant difference, which is why I'm rushing through this so that I can show you how to turn it into a game. Set up, set the flies going, and catch them. So there's the frog, and it's going forward, and it's spinning around, and I want to see if it can catch a fly. Of course it can't catch a fly. And the reason why is because we haven't told it to catch a fly. So, let's go down to our program. And what we're going to do now in section 8 is we're going to create a detection. The documentation says collision, it's actually detection. And while we're in flies, on collision with a frog. Dun, dun, dun. Die. Agent. Delete. Okay, save. Run code. And catch flies. So now, there are no flies to catch. Of course. Of course. Here we go. Here we go. It missed. Oh, there we go. We ate one.
It did.
And will it eat another? No. But that's what happens when you do a simulation. Now, is that realistic? No. How would we make it more realistic? Well, we could have the frog move around randomly. We could do any number of things. What I'd like you to do is turn this simulation into a game. So how do we do that? First, I'm going to save, and then I'm going to run code, turn off the flies, because that's just annoying. And let's take a look at our frog. Right now, we're going to create a procedure. How are we doing for time? Can I do this? Sure. All right. I'm going to create a procedure. Procedure is just a series of commands, and I'm going to call it keyboard controls.
Could I interrupt you for a quick second? I just want to point out to our viewers how Shar seamlessly integrated logical conditional formatting, like while she has a condition in there, she's now forming a procedure which essentially takes a keyboard input and is actually gamifying the whole simulation, as Shar talked about before. It's very essential because it is organically, students are learning these conditions or logical loops, and to do something, to do an activity, or to make the fly move or frog eat the fly, which is a very organic way of learning conditional formatting, if else loops, whiles, the procedures, as well as understanding of variables. Thank you, Shar.
Oh no, this is actually, I forgot the computer science part. When I have more time, we talk about difference between key held and key types. Key held in this particular case is when you mash it down forever. So when the right arrow is mashed down forever, what are we going to do? Well, we can say turn left or turn right, but I don't think that's really what we want to do. Movement-wise, what we want it to do is turn left by 5 degrees, right? Not 90, but 5. And we want to turn right by 5. And this one's going to be forward, and this one's going to be backwards. So you get the kids starting to think about what you want the keys to do. So when we go forward, we're talking the frogs. We wanted to go forward, up arrow, 3 keys. And when it goes down arrow, we want it to back up. We could say, turn around 180 degrees, but that's not what we want to do. Get rid of the forward by throwing it in the trash, going to the keyboard and selecting procedure and call keyboard controls. Now save, run code, and set up, fly around, and froggy go courting. It's not moving. No, it's not. It's moving by 3. Right. There we go. So, down. Control that keyboard. And it's faster than the flies, so it should catch them. Yeah, mashing down. Oops. So anyway, that's one way of gaming it.
I'm running out of time, so I want to tell you folks that the frog, oh, I have 5 minutes? I have 5 minutes, everybody. All right, so the gate movement via keyboard. Now let's talk about how do we make it so that we can keep score. When the frog dies, no, the frog never dies. When a frog collides with a fly, this is Charlotte going off the keyboard, off the script here. What we're going to do is we're going to take the interface and set data box score to score plus, so I go to math, score plus 1. And then the fly dies. Okay, save, run code. Is everybody clear on that? All right, here we go. Setup. Flies. And fly around. There we go. And oh, I think 5 degrees is too slow. Watch the scorecard. Yeah, we got a 1. Just want to do this enough so that the game. We got a 2, we got a 3. So that's how you keep score in StarLogo. Thank you.
Jack, who is with us on today's meet, is talking about, he actually explored the math blocks, and he was wondering if we could talk a little bit about what are the different math blocks and how we could use them.
Absolutely.
Thank you, Shar.
Let's go back to catching flies and scrolling down. By the way, you can do fairly complex procedures in math. Pi, generate a random number. This one requires a little explanation because the random number is, if I do 1, it counts 0 and 1. So, let's go over to, let me just create a widget, edit a widget, new widget. We're going to call it random. Add the widget. It's a push button. And we're going to make a new data box. We're going to call it outcome. And put it over here. Then take off the edit widgets. And here, when random is pushed, interface. It gets confusing after a while. Set the data box outcome to random 1. Okay, so I hit save, run code, setup because it has to have setup, and then random. 0, 0, 0, 0. It's always 0. What if I said 2? Maybe it doesn't count 2 anymore. Count 0 anymore. Save, run code. Gotta remember to do that. Setup, random, random, random. There we go. We got some 1s and 2s. So, for the flies, for example, I would do something like this. I would do movement, forward, turn left by a random number between 1 and 30, and turn right a random number. So math, random number, 60. Why did I do that? Because 30 to the left and 30 to the right just makes it go in the left degree. So 60 to the right makes it go either left or right. So that's random. The remainder of a number, in some cases you want to know how much hamburger meat you have left over. So you would use the remainder of that. Sine, arc, square root of, log, logarithm, raising something to the power. The larger of some number, some variable, and another variable. Round to, it's fairly self-explanatory. Did that answer your question? Going back to the game, as Rashmi is responding to folks, if I go to the world, I could change it to 20 flies. And instead of black, I could choose a random color. Now save. Now compile. Oh, there's an empty socket. Okay. Oh, I know why it thinks there's an empty socket. Because under flies, there's a lot of empty sockets. All of these things need to go to the trash. Save, run code, set up, fly around. How come it's not setting up? This is when I pull out my other one, but it's not working with me, folks. I'm sorry. But time is up. Other things you can do is you can change the shape of the frog. You can create Venus flytraps. And then keep score as to who's eating more. You guys want to see galleries? If you go to my profile, you'll see that there are resources available, and you can pick through here a variety of people's stuff that's been made public that you can then remix and use in your class.
We have literally 5 more minutes, so I'm going to quickly go through some of the resources. It is really incredibly rewarding to hear from educators who implement this in the classroom. And as a collaborative group, there are around 20 educators in BPS who are doing StarLogo TNG, StarLogo Nova activities in their classrooms. So we highly encourage you to please explore these activities and more. What I am displaying on the screen currently is a Google Classroom, which allows you to look into more of the activities that are available for StarLogo. There is a simple treasure hunt game programming activity which you can do with 3rd graders. You can also take it and extend it to high schoolers. There are worksheets, there are starter games, and as Shar mentioned, you can always explore within the parameters and play with it and see how things work. Couple of questions were around freezing of StarLogo Nova, and sometimes having an Ethernet port connected and having a robust internet connection really helps. But make sure you always save your project in your profile so that you can go back to it and you do not have to start from scratch in terms of reprogramming or reallocating your blocks. Another activity that I want to point out is the game design activity. There are some how-to files which talks about what is the space land orientation, what's the web land orientation, so you can look through different how to edit levels, how to edit breeds. Shar created a procedure, and there are some simpler procedure examples that you can play with your students so that they understand the logic behind creating a procedure. We also have a termites activity programming module, which is a really wonderful way of integrating some biology, some scientific concepts into programming, and which is one of the really great parts of StarLogo because it lends itself towards integrating in different modalities, in different classrooms, in different subject areas. So please do explore register for the Google Classroom. Please feel free to look into these activities and see how you would adapt them. Of course, I highly encourage you to join the collaborative group. We are always there. Shar and I are always there if you have questions, but being a part of a big collaborative group really helps explore concepts even more. I'm going to quickly switch back to one of the important sites that I wanted to point out, which I mentioned earlier. This is the Global Hour of Code website, which it's a global movement, as you already know. It encourages students to get involved with computer science, and tens and millions of students, educators, adults like us are involved in this movement. Obviously, there are 40 languages that you have tutorials in. And you can see just from this map how many people, how amazing the response is to this event. So please make an attempt. Please take the word out in your school, get involved, and I'm going to show you our BPS Hour of Code website where you can pledge, which also means you can have more educators from your school involved, more students involved, so that they can not just do an hour of code, but continue doing this as they go forward, because this is one of the basic literacies that is very essential for our students. Here is, I just wanted to scroll down quickly so that you can see there is an interesting $10 opportunity on the Hour of Code. If you register, all educators get that gift card, and it's sort of a tiny momentum, but you can, if you get your whole school involved, there is a $10,000 prize that you would get entered in for the raffle. So please do go to this site, look up different types of activities that are provided. There are 1-hour activities that you can get involved in, you can use in your classrooms. If you don't have any equipment, you can definitely use activities that don't need technology. They are engineering, computer science activities that promote computational thinking, and you can explore that. So having said that, we are going to quickly switch to our BPS Hour of Code website, which this is the button where you can take the pledge. Please do, if you are already not here. We have all the schools, upwards of 50 schools have registered, and they're doing Hour of Code, which is from December 7th to December 11th. What I want to point out quickly is the contest, and it's a student contest, and the prizes. We have generous donors and really wonderful company that are involved in donating prizes. Acer, Follett, E+ Technology, Mass TLC, Twitter, who have granted really amazing prizes for these competitions. We have 8 challenges, which range from Scratch to web design to app design, computing with mathematics, fractals, flash animations, game programming, video challenges. Please do get involved. The submissions are during the week of Hour of Code, which is December 7 to 11, but you can work on these challenges throughout the month of November and up until the December 7th, and you can submit them. There are submission guidelines and certain general rules, so please look through them. Please submit. Please encourage your students to participate in the contest. It really gives them a boost when their projects are recognized. Thank you so much. Last but not the least, I just want to end up with this StarLogo game programming webinar ticket, which is our exit ticket. A couple of things that we want to know from you. Obviously, how you like the tool, what are some of the concepts you have integrated, but key questions for us is in our orientation handout, we have included some concept questions, which sort of gives you programming blocks, and you can look at them and you can analyze them, and there are certain key questions in it. please take a time and look at those questions and go through the orientation activities. This is one way of, even having a dialogue with us regarding what you see, how you would like to get involved with this, or if you have questions about certain concepts. We do look forward to your feedback very much, so please do give that, and you just click submit and we should have that. Thank you so very much. We are absolutely out of time. A big round of applause for Shar. Thank you so much, Shar. It's a pleasure. And we hope you will be computing during BPS Hour of Code and onwards. Thanks again.